Wait, where'd the BRB go? Oh, okay. It's fine. What the hell is... Oh. Wait, how could you see it? American version. Hmm. Hmm. Diagonals don't count. Alright, this is secondary. So I'm going to draw numbers one at a time. I assume that's just an example to speed it up. But we draw number one at a time. The numbers only go up to... they go up to too high for bit stuff. Sadly. So they go to 100. Or 99 at least. Yeah. But there's no 100. Well, we could do two registers. So if we just OR in, we store a number for each, we store a register for each row and each column per board. And when we AND it with the total drawn numbers, then if any of them are equal, there's a winner. I think the dummy only goes up to 20 something. So we could do a simple version for the dummy to see if it's a viable solution. So we're gonna have we're in CRLF, not anymore, LF only. Do that. Table. So from here it should be, this row is empty. The first one's empty. But we could just do this. So now we're going to get 5 numbers. Here's Nostrum. Oh, it's Crimstock here. Crimstock's good at... Oh, he's not. It's Longbillion. Yeah, Longbillion is a slippery devil. Like... And we should be able to do skip empty is true. Let's just do this. This has got a bunch of extraneous shit on the end of it. Why is that? Oh, I'm not printing draws. Oh, I need this as tables. There we go. So that looks like we're getting rows fine. So we're going to this is just this is number strings. Actually, we don't even need to just do this for it can be 0. I don't see any. I could put some more error detection and validation, but I don't think it needs it. So now we need. What's our plan? Our plan is we're going to have this is basically a vector 5. Hey, Crimsock. Oh, you just if you'd messaged like 3 seconds ago, you'd be in this deathmatch with your guy that just yells at people that they missed him. Are the other these are 5x5 as well? Okay. So we're just gonna have int 25. No, that's 5 times 5. Int. Do I really want to do it this way? Let's do a row as 5 hits. And then we're gonna do do we want to do it this way? Tables, raw tables. Actually, no, just want one raw table. Then raw table, row index. This table row index is greater than and we're gonna process our table and add it to our collection of actual tables. And the actual tables are going to be how's the game going? Oh, I'm winning. Sweet. 30 seconds left. Can we kill Kogi one last time? Can Kogi kill us? Oh, if Kogi kills us, is a tie. That's terrible. Oh, he's trying to run. No, mistake. If he did his drop fire, he would have probably won. Or got a tie at least. Oh, but he's getting a point. Oh. Oh. Oh, he missed the last shot. Would have got him to 4. Okay. We have our rows, we have our columns. Although, we don't actually need, we don't care that they're rows and columns. We just have 10 of them. So here we're going to Okay. I'm gonna move these out of. I feel the programs are getting a bit more serious now. Table, table, and raw table. And what we're gonna do is 40.4. This is gonna be row. Hold on, so we need to do 5 rows and 5 tables. 5 columns. So yeah. Entry 32. Then we do C colon 0.4. So the value we're reading is raw table dot rows are C. And we're gonna do entry r equals shifted by that. This. And then table index equals entry table index plus equals 1. Entry. So this gives us our rows, and then we do the same for these columns. Okay. And now let's just print. Can we just print tables? This is. So we'll just make. It's a table dot rows columns. What's the lines V? is not a member. It's Rose. I got it right in one and wrong in the other. God damn. I'm trying to get it. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 9, 10. There's 3 of them. There's 3 tables. Seems good. So now we have our tables. We can draw draws. All draws equals draw. That might need to be cast. We'll see. Then for tables, if for entry rows and columns, if entry and all draws entry oh, what is our output though? We actually do need to store all the tables in a dumb format. Oh, wait, hold on, we'll see in a second. We'll see in a second. Comma. Yeah. Oh, in fact, this is wrong. This is cast 32 1. Well, this should be break. Draw. In fact, this should just be exit. What equals 2? Is that right? Yes. Okay, that's a very small test case. What on draw percent with draw on draw 24 again matches what this says, right? Finally 24 is drawn. Seems good. We've only tested a row win, we've not tested a column win. But let's pretend. Shall we? This is kind of janky how this is doing this. Let's do fun. Winner, comma, draw, equals get winner. Not closed. What? Oh. Table index. Oh, here. When it was 2 on draw 24. Seems good. Is everyone following what we did there? Or does someone need or want an explanation before we go into making it more complicated? Because this won't actually work on the actual input. Alright, we're playing bingo. Here is the advent of code. So basically, this first row is the numbers drawn in order. This is the random barrel that they're pulling out of. And then we've got a bunch of tables that are playing bingo. And you win bingo when you fill a whole row or a whole column, which I can't do with the mouse here. So you have to detect which table wins the game. So you go one digit at a time through this, and the first table to fill a row or column is the winning table. We also have to do a thing at the end. Let's look at that just now. Alright, so how we're doing it is we are making a bit mask for each. We're making 10 bit masks for each table. So for each row on the table and each column on the table, we make a bit mask. So we basically shift by the value and then store it. So our record of tables is this rows and columns is 10 U32s. So to check if something's 1, basically we read the next number, we OR that with our all numbers drawn so far, shifted by whatever the number is. So we're making a mask of it. And then we just go through the tables and we check each row column for each table if where is it? Get winner. Basically, if our row column and all the draws so far is equal to the row column, that means the whole row or column has been filled, so we've got a winner. That is the plan. And then we have to do something else, which I'm going to read now. That we're finding the sum of all unmarked numbers on that board. Now it's just called on the board. Sum of all unmarked numbers on that board. Can we get that from the bit masks? No. We need to make another bit mask in the board, which is all the numbers in the board. Then we complement away the drawn ones and then convert that into a thing. That's doable. Should we do that first? Maybe we should do that first. So the bar in the ointment is that in the actual data inputs, it can go up to 99. So obviously, the biggest unit we can have is a 64. So we can't actually just up these U32s to U64s and it'll work. It's not going to happen because it's going to blow off the end. So we need to make a new data structure, which is like 2 U64s that knows how to, like, if you're shifting from one, it goes into the other effectively. So that's going to be a bit stickier, but I want to do the dummy one first just to prove it worked, which it does. So now we either upper game to 100 digits, 100 number, 100 max number, or we work out the answer. I think we do this bit first because this is going to be a bit irritating. In fact, we don't need to store. We don't need to store. We just need to iterate over the first 5 of these. We need 2. Where's the thing? All bits in table. Let us do, let's say, a mask as a U32, and then let's replace all U32s with masks. Except for that one. Are we still running? Oh, apart from this dumb shit I just typed. Yes. So we're just going to for 0 dot dot. We only need half of it because the first 5 inches are the rows and the next 5 inches are the columns, but it's the same. So we just do for blah 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 mask or equals table dot rows and columns it. It's pretty small. Maybe we should just make this return the actual array. No, we need the mask. So then we're gonna do here. We'll do if winner is less than 0. In fact, we're just going to do assert winner is greater than 0. Why are we being silly? And then we can do we just replace, how about instead of that we do winner is a table. And this can be return tables. In fact, we can just do for star and just return table like this. Right. Start winner. It's not equal now. And then now we don't know the index. Do we need to know? Oh, we don't need to know the index though. What we need to do is do all bits in table winner, and then remaining bits equals all bits and not oh, this can think. And then we just have to convert these into numbers. Which there's probably a smart way of doing, but so the smart way is the thing you do to find the least bit, and then wait, have we got one in the library actually? Because that would make it super simple. LCB maybe. Least. Let's do some assembly. Lowest set bit. And then do can we do, was it TZ? Zeros. So it has to work out, so we remove that's GPR. We need the, I don't need the brackets. Then we do TZ count. Result colon 64. Result bits GPR. Is that it? So compile still. Still compiles. So let's try uh, $15. That's one, isn't it? No, we need to do. We need to assume it's not 0. List of 1 equals 1, comma, set bit 1. Oh, so 0 is wrong. Right, I really need to do that one. 0, 2. That looks right to me. 32 is 5. Okay. Success. So now we can do numbers from bits. Here we go. I'm gonna do if bits 0 turns up. Then actually while bits lowest set bit well, let's implicitly cast. Let's use this now. So if that's the 0th, it's basically +1. So we do array add salt, comma LSB +1. And then we do bits equals not LSB not 1 shifted by LS. I think. And then we're going to do numbers from bits. 0, B, 0. What are we doing wrong? We need to cast this. But we can't cast. Oh, we could actually. It's -9. 2, 3, 5, 8. What did we type in? 2, 0, 1, 2, 3, 4, 5, 6, 7. This would be 0, 1. No, we're not. We shouldn't add 1. Adding 1 was a mistake. It's just that, right? 1, 2, 4, 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so the winner. So winning. What are we supposed to do? Let's just do what they do. Sum of all unmarked numbers Actually, we could just. Don't need the array. Just need some. Okay, we're gonna keep with our naming scheme. It's a good naming scheme. Percent times percent equals percent. This will be some blah blah times the I mean, it looks pretty good, right? Bunk. Bunk. This is part one. What's part two gonna be? God damn. Did I did drink tea. So now we shall make mask an actual thing, which is going to be high as U64 and low as a U64. Do we just use operator overloading or do we use functions? I think we can overload. But probably better. Okay, let's just operator plus a colon mask. Okay, no, not plus, or. Are we using or? What are we using? That's only right what we actually need. I think we're using or and complement. Barring this, then we're adding these two together. So, actually, hold on. We need to change this a little. Practically, we need an operator or because we need to do it with a. We do it with an int. So, gonna or in. Do we ever or them? Let's just look for pipes. Okay, let's just do it in order. Blah, blah, blah. So here we're ORing onto a mask, but this is going to be an int. So we need to do then if the result equals A, if B is greater than 64, because one shifted by 63 is a thing, right? Yes. So if it's greater than 64, then it's going to be or equal 1 shifted by B minus 64. Else, let's rule by B. Okay. Is this stuck in tile? Oh, we've lost her. Where's this? Is it S? Where's my goddamn... Lot us here. Running terminal. There we go. Type 1 to G64, type given S64. Where's this? Do we just make this a U64 and then cast into it? No, and then maybe we could return a result. That might help. What's that give us? Can I cast to a struct? Okay, that's fine. Can I cast a struct? Okay. So this we are adding. Again, we're using adding an index or not an index. So I think we do the same as this for and. And we do we're gonna need the full version, which is easier because you just do both of these things. So, okay, so it's high. Okay. Does that take us to? Here we're gonna do mask or equals LSB. And then that. Here. Oh, we need the R for that. Okay. So. Then here we're just gonna do this and this. Oh, and now this is a struct, so we can't do that. So actually remainder. And now we need to make lowest set bit work with a mask as well. And here, you can't do a remainder dot high or remainder dot low. So blah blah. To do this. So this now takes a mask. Hold on, we need to keep this one. And what we do is if bits dot low return lowest set bits dot low. Otherwise, we'll return lowest set bits dot high plus 64. And here, what are we doing here? This shouldn't. This should just be. This doesn't even need to be cast, I don't think. Take what did mask get result? Wait, row shouldn't have. This should just be. Oh, for fuck's sake. What we got now? Problems everywhere. But this isn't. So we actually want to make this U64. Kind of cast to a strut. This is just the draw. Did we make it do a U64 or something? Yes. Oh, we need equals. Turn A dot high plus B dot high and A dot low plus B dot low. We're back running. We're back with the right answer for the dummy. Let's run it on the actual input and see if it crashes or works. Seems to have given us an answer. It looks like a legit answer. Amazing. Let the spread win. Which board will win last and choose that one? Okay, this is actually easy, I think. So what we need to do is save this. Oh, we can save this as this. I'm going to save it as dummy B. I'm glad I was worried there because like that first one was obviously quite a lot of effort. So I was thinking, holy shit, if the second part is like yesterday's, that would be crazy. But they've front loaded it this time. Well, I guess it would depend on how you did this. Let's see. I've picked this up being easy now, right? Let's see how easy it actually is. So instead of returning when we get the winner, what we want to do is get loser. And how to do that is at each draw, we're going to go through all the tables. I don't even need even a pointer anymore. We just did this. And if okay, we're gonna give it the old brackets. So if this table has one, we're gonna remove this table. Continue draw. And then here, if tables.count, we're gonna assert tables. Actually, do we just put the test in? Would they give us a situation where two boards one and the same? I don't think they will. Let's just assert table count is greater than 0. And then if table count equals 1, we'll return start tables 0. comma, what? Oh, this is actually in here. Draw. And we shouldn't actually be able to, I mean, we can just return null -1 as usual here. Let's just winner, loser. There are problems. Assertion failed. 47. It did go to 0 and the 1. Why is that? Because I fucked up. Or we're in the dummy. The second board is the last to win, which happens after 13 smash to call. That's when the call is completely marked. Did I screw that? I feel like, hold on, I mean, it says the dummy, the second one wins. When this column fails. Where are it? I think it's made a silly mistake. Table, rows, and column. Remove the table, we continue draw. We shouldn't continue. We should continue table. No, that should have. Oh, that fixed it. What's the answer? Oh. If you were to keep playing to this point, the second board would have a sum of unmarked numbers equal to 1 for 8. Oh, but we have to work out the table before it. When? Let's undo our renamage. So what we're actually doing actually we need to do it here. We do if table.count is 2, then this is the winning table. Wait, what are we reporting here? Second board is the last to win. Chance of things. If you keep playing to this point, the second board would have a. No, it is the second board. So. Hold on. Let's do. The last winner. Oh, but we. I mean, are all boards guaranteed to win? How's this deathmatch looking? Oh, Crimsock, Kogi is owning. But he seems to be stuck low down. Maybe I can pick up a Crimsock kill. Oh, Kogi's gonna get in the way though. Oh no, he's not, he's running to the right. I should change my font. Why would I change my font? What font? This font? How did he not see? Oh, he's aiming up. Why is he aiming up? Bug. Program is bugged. It's all over. GG. Stomp for Kogi. I think you've jinxed my guy into being a dum-dum. Kogi's trying to punch you desperately and finally gets you. He's coming for me. Oh, if he resets me, maybe I can get a dignity restoration. $20 to get 6 kills. Seems doable. Oh, the final kill. 8. Good tally. Right, where are we? So when we run this, what do we get? We get a stack problem. Because I undid the thing I did. Assertion failed. Because this should be continue table. I guess we could put this here. This is wrong though. Why is it wrong? So we 140 times 13, but we're doing 161 times 6. Am I still in the big data set? No, I'm in the little data set. What am I not understanding? Figure out which one will win last. That way, no matter which board it picks, it will win for sure. In the bar example, the second board is the last to win. Is this because it's switched to a column one and my thing isn't actually working, or what? You think we win at draw 16? Where 16 is the one before 13. Oh, because we're early outing before it's 1. That's the problem. This is what we actually want to do. There we go. Woo! We're exploring the ocean. It's all awesome. Okay, GG. Now maybe I fix my guy bug. Or maybe I get some food. Maybe we update the GitHub. Very good. Any chatters done it already? Want to share their solutions? Also lurkers. I'm not that starter followers that I'm going to subject myself to light mode. This is true. You're putting a heavy burden on me. I just used all my brain power up on that puzzle. Now have I got the energy, the mental energy to debate this balance of scales that one follower makes to my career? It could be the tipping point. What if I switch to follower only chat? Will that sway you in any way? Oh, you have followed already? Okay. Well, what if I finished Advent of Code? What if I just stop streaming right now? And you'll never know if I switch to light mode. How are you going to handle that? Look, he's aiming up and there's no one above him. How is he? Is this wrong? Okay, that's fair. You need positive proof of a search. Fair enough. Wait, but what if? What if? Oh, what light mode are you talking about? What? Be more explicit. That's two. That's no. I'm not installing a plugin. Get a grip. That's never gonna happen. And it could. Can you just manually edit the CSS? Does that work? That would suck though. I'm surprised that event doesn't have a button to push. Well, what I was gonna ask, so you said I have to switch to light mode or you unfollow. What if I switch to light mode and then switch back? That would have fulfilled your task or switching to light mode. You never said I couldn't switch back. So what if I did that? Okay, so you basically have like a 10-minute timer with which if during that 10-minute timer we're not in light mode, you will unfollow. And anytime you're there, that 10-minute timer is renewing. Okay, I've got a 10-minute timer for you. Oh wow, I just made the game really hard for the Bye Bye Lumbrillion. Gotta watch those 10 minutes. They're dangerous 10 minutes. I hadn't contemplated this. This is funny. Wee! Oh no! Is the aim not working if it's vertical, maybe? I need to kill you, Crimsock, to test my theory. Also, how's he not seeing goddamn Lombillions? Right? Oh, it's below him. That's why. Okay, got him. And now we have reversed, but it's completely in the. It's a dumb. It's dumb. You know what we could do? Why is aiming up? What is it? It's 3. We set from it, we set to it here. Is $3 used anywhere else? It's not. How did we end up with. I don't understand how we ended up with -3 and 2. Oh, because we're taking one off. Because it's not sub minus, that's why. So, let's just do. If we comp equal aiming up at 0, and then set dollar aiming up dot 0, then that should mean if it's currently 0, we set it to 1. Let's try it. Oh, Control F5. Yeah, that's gonna work. Didn't see you again. You're like a ninja, just ditching through the gaps. Three? How is it 3? I'm kind of confused. Or maybe just never clear, but it should clear. Or maybe it doesn't. I'm gonna shoot you, Crimsock. It's gonna happen. It's happening. If you want to just type some more stuff and fill the test out, the table out, that would be nice. Why does your guy struggle so much? Can you not just make him like stand still or something? That would be good. Oh yeah. But the problem is we can't see. Well, you typing doesn't actually help him. Eat it. 8:15. How? Wait, have I got another debug in here somewhere? There's something screwy going on. Look, the star three's here. Oh, was I in regex mode when I did the search for $3? Bang. Look. These can be $1s, dude. These don't need to be $3s. Which means this can go back to sub minus 1. Let's leave that on for now. Okay, now you should go. Yes, he switched to going up. And after he kills your dumbass, you should go back to aiming down. God damn it. And now we're screwed. Maybe he should left if there's people above him. You know, try to punch him in midair there. Wait, why am I yelling noob at someone? I didn't kill anyone there. Or did I? Get rid of this debug. zigzag back and where did we fix up down? Where are they go? I kind of want to start a deathmatch, but I feel it's cheating if I do it while there's a gap here. There we go. Oh, we've got some interesting little tiny level sizes. It should make Kogi's guy better. Oh, unlucky Kogi. Uh-oh. Vengeance is going to be his. Or not. Gonna rack up the kills here. Just recharges some ammo. I kind of want to put my thing back in and interrupt. We'll oh no, Crimson, you got killed by Kogi. Actually, this needs to be... Oh no, you got 2 kills there. Oh, I've got 5, never mind. It's all good. That's like 3 times the deathmatch has been a timed round. You got me stuck in a loop. Maybe there should be like a timed... swap as well. Or just a random swap. we can do. Oh, that jumps though. So we just do this. Oh, Kogi's getting a punch, or I'm getting a punch. He's got 10 points? Holy, when did this happen? Holy crap. I turned away for a second. And he got 10 kills. We should have a max kills per round stat as well. Get his kills per to win though. He's got a huge KDR. KDW. Okay, let's see if this compiles. No. $5.15, I've gone too high. I guess we can do without the apples. Oh, we weren't even using the apples because this was too low. Okay. Okay. Thanks for stopping by, everybody. Will we go raid someone? Mark is jaying it up. Let's give him. Only 11. So many of you all lurking. Lurky lurkersons.